In this section, we are going to look at mass to mass calculations. So grams is what we're talking about here. So let's start with an equation. This is our regular Haber process. It's been balanced, and our question is determine the mass of NH3 produced when we have 10 grams of H2 reacting with excess N2. So we're going to ignore this excess part. This is going to become more clear in a future section. We're just focusing on the mass and this mass right here. So to answer this problem, when we have different substances, NH3 and H2 are different substances. So when we're asked to go from mass of one to mass of the other, it's going to take us 3 steps. Those 3 steps are going to be, step 1, we are going to find the moles of substance A using our boxed expression. Step 2, we're going to find the moles of the other substance using our mole ratio, and that comes from our balanced equation. And then step 3, we're going to answer the problem, which will probably require us to use the boxed expression once again. So I want to delve into these 3 steps a little bit more, but before we do, I'll remind you that this is our boxed expression that contains grams and moles and Avogadro's number, and X is our molar mass. All right, so let's take a look at what we're going to do in these 3 steps. So like I said earlier, step 1 is we're going to find the moles of substance A. Now moles of substance A is going to be here. So H2 is going to act as substance A. We have the mass. It's the very first one in the problem. And as we proceed, we're going to have this be substance B. It's not super important you really understand A and B as long as you know A is what we're going to do first. So in step 1, we are going to find the moles of substance A. So let's write that down. We're going to find the moles of H2, and we're going to write down that we have our 10 grams of H2. So write down what you're trying to find, set it equal to what you know, X in a line, and now we're going to go to the boxed expression. So we're talking about grams, we're talking about moles, meaning we're talking about X grams, and we're talking about 1 mole of H2. So we're going to put that 1 mole of H2 up top, and then you're going to go on a side and figure out the molar mass of H2, which turns out to be 2.016 grams, and that's going to go on the bottom so that our units cancel out. And if you type that into your calculator, 10 times 1 divided by 2.016, we should get 4.96. So let's keep that on our calculator. Do not clear that number off. That is step 1. Step 2 asks us to find the moles of the other substance. So we're going to find the moles of NH3. Again, this is acting as substance B here. And we're going to carry this 4.96 moles of H2 that we just found. We're going to carry it along. Okay, so that's going right there. So X in a line. Now we do have to remember that our mole ratio comes from our balanced equation. So looking up at the balanced equation here, there is our H2 and there is our NH3. So let's note that we have a 3 in front of the H2. We're going to need to put that 3 somewhere. And I guess we're going to want to put it on the bottom here, right? So that we'll cancel with the moles of H2 up top. And then the rest of this question is about NH3. So if you look back to the balanced equation again, we have a big 2 in front of that NH3. So let's put that number up top. So now on your calculator, since we haven't cleared it, you should have 4.96 on it. You can go times 2, hit equals, and then divide by 3. And if you do that properly, you should get 3.31 rounded to 2 decimal places. So we've found the moles of NH3 at this point. Step 3 wants us essentially to answer the question. And of course, the question is asking us up here, we want to find the mass of NH3. It doesn't necessarily always need to be mass, but in this section, it is mass. So that's what we're going to find, the grams of NH3. So let's carry along our 3.31 moles of NH3, X on a line, and back to our boxed expression. So once again, we're talking about grams and we're talking about moles. So we're talking about 1 mole and the molar mass. So let's put the 1 mole of NH3 on the bottom, because that is going to cancel out with the 1 up top. And then if you go figure out the molar mass of NH3, it should weigh a little over 17. So your final calculation becomes 3.31 times 17 divided by 1, and you should get 56.32 rounded. So here is our 3-step method. I would say it's not my preferred method of doing it. I want you to click on and find part 2 of this video series. It's going to be the exact same question, but it's going to be combined in a much more user-friendly way. All 3 steps are put together. there's a little less work actually involved, and I want you guys to proceed not necessarily using this method, but I would prefer you using the other one. So click on the link and go check that one out.